So, hello friends. Our today's topic is why COD is always greater than BOD. So, this is a very basic concept, but I have found that there is a lot of confusion regarding this simple concept. Before I get ahead in this lecture series, I kindly request everybody to kindly like, share, and comment on the video content. This will encourage me to make more such informative videos. Thank you very much. With that, let us start with the lecture. Uh, Let me also give you some background why I decided to choose this topic. So whenever I visit any industry, I try to ask a couple of questions to the industry people who handle ETPs. So first of all, I try to understand what is their BOD and what is their COD. The major reason behind this is if you know BOD upon COD, this ratio, it will help you in deciding the strategy of your communication which you will be doing with the person. So just for example, if BODI, if this ratio is approximately equal to 1, this implies that almost all the components of the effluent are biodegradable. You can biodegrade it using, so this will help you to suggest a strategy. So it can be a biological treatment primarily. But if BOD is very less than COD, this means that most of the effluent is not biodegradable. So it will require some different processes, and there has to be some more analysis which needs to be done. So the major relation between them is the BOD is always greater, is always smaller than COD. And why is that so? That is the concept which we are going to look at. So what is COD basically? So COD is nothing but the amount of oxygen which is required to degrade the material or substrate. But this oxygen requirement is proportional to the maximum number of electrons that can be removed from the substrate. Now just say for example, we'll take example of acetic acid CH3COOH. If I want to oxidize it, I will require 2 moles of oxygen, which will give me 2 CO2 plus 2 H2O. Now let me write half reaction for oxygen, that is O2 plus 4E negative plus 4 H3O plus, that gives 6 H2O. This is the half reaction for oxygen, which implies that 1 mole of oxygen can remove 4 moles of electrons. So if you see, in order to oxidize CH3COH, you require 2 moles of oxygen, which implies 8 moles of electrons are required to be removed from the substrate, which is acetic acid here. This is just for your better understanding. Now, when the organisms are present in our effluent, so for example, this is my effluent, and we are aerating it, and also the microbes are growing into this oxygen. The microbes are also growing inside this aeration chamber. Okay. Now, if a biological substance is growing on the effluent which we want to degrade, the effluent is nothing but a carbon source, and this carbon source is utilized by the organisms for producing new organisms That is one. And other thing is they oxidize it using oxygen, or simply they oxidize it. So the electrons which can be removed, the total electrons which can be removed, the total electrons which can be removed have two different destinations. One is they are incorporated in the new organisms, because these organisms which degrade this material, they are also incorporating these electrons in them. So that is one source, that one destination, and second destination is of course oxygen, as we saw that if oxygen is being used to uh, oxidize the given effluent. So as we said that 2 moles, that 1 mole of oxygen requires 4 electrons. So 4 electrons. So some electrons will go into the oxygen, that will incorporate in oxygen, and some will get into the new organisms which are produced. And this concept actually forms the basis of the COD balance. Now, what is COD balance? So total, if I write like that, so total removable electrons from a substrate, from substrate, as we said, so this is equal to sign. So total electrons, which I am writing on the left side, so their destinations are new organisms and oxygen. So electrons present in organisms plus electrons removed by oxygen. So these are the two destinations, and based on this, you can write it in another form, that is minus um, delta S COD is equal to delta X COD plus minus delta O2. So minus delta S COD is nothing but the substrate removed as COD, which you can measure in kg COD per meter cube. This represents total removable electrons from this effluent which you want to treat. Delta X COD represents the microorganisms produced as COD, kg COD per meter cube, and these are the electrons which are present in the organisms, the, plus the oxygen which is consumed. So this is the oxygen consumed, which can be expressed as COD, that is kg COD per meter cube. This also represents basically the electrons taken out from the system. Now, if you concentrate on this equation, now delta S, let me write it once again. So that's what we saw, minus delta S COD, which is the total number of electrons which are removed from a given effluent. Then this is the electrons which are incorporated in the biomass, and these are the electrons which are taken up by the oxygen. So this is nothing but our total COD which we refer to. This is nothing but the COD because these are the total number of electrons. So this is the total COD of the matter, and BOD is nothing but this. This is the BOD, that is the biological oxygen demand. So this much O2 which is required by the organisms to degrade a matter is BOD. Now you can see that BOD doesn't incorporate this term. That is, BOD doesn't take into account the electrons which were incorporated in the biomass while the organisms produce new organisms. So that is the reason you can see that COD is BOD plus delta X COD, and that's the reason COD will always be greater than BOD, and it may not be even same. It will be approximately similar. Whatever intermediates or byproducts which are obtained during the new organism formation or different processes, they should be added here. And there is always a loss in some electrons which are given to other side. So that's the reason COD can be approximately equal to BOD, but it will never happen that COD or BOD is greater than COD. Yeah, thank you. That was all about the correct reasoning of this boiling question, why COD is always greater than BOD. And thank you. Please kindly subscribe the channel and like it if you found the content informative. Thank you very much. Let's meet again.